Hi, I'm Herb Gross, and welcome once again to Gateways to Mathematics, where today we will introduce the final component of our course. Not the final part of our course, but the one missing component. In other words, this is the first time that we're watching a tape and having a discussion on the solutions to an exercise set. Now, remember what the ground rules are for this. I think I'd like to make sure we all understand that. After you've read a module, and after you've studied it in the study guide, there is a self-test at the end. You should have tried self-test 1 Form A already. And self-test 1 Form B gives you the same problems, only with different numbers, in case you need more experience. What we'll be doing in these lectures is we will be doing every exercise in the self-test Form B. So you'll have a chance to be able to hear and see the solutions. And if you prefer, you can watch this tape before you try Form A, depending on what your best learning mode is. However, it's very imperative that before you watch the tape, you try the problems. If I do my job right, it's going to make the problems look easier than they really are. It reminds me of the story of the man who decided to go into the swimming pool, and he saw another man nearby. He said, "Tell me, is the water warm?" He said, "Oh, yeah, it's warm." And the fellow dove in and he almost froze to death. He came out blue. He was shivering. He said, "I thought you told me the water was warm." He says, "Gee, it looked warm." See, basically, these problems will look easy if all you do is watch me do them for you. I want you to get involved. I want you to try them. And then that way, when I go over them, hopefully they'll have much more meaning to you. And so with that as an admonition, let's go over to the board now and go through the problems as best as we can. In the first 5 problems, I am going to mimic what we did with Roman and Egyptian numerals, and to show you the arbitrariness of the nouns, namely the symbols that were invented to name the various denominations for the powers of 10. I am just taking different letters of the alphabet to do that. In other words, in the next 5 problems, the letter N will stand for 1, O will stand for 10, P will stand for 100, and Q will stand for 1,000. And if that really bothers you, I mean, I hope you don't do it this way, but if it really bothers you, you can say, well, listen, wherever he's saying N, I'll think of I. Where he says O, I'll think of X. Where he says P, I'll think of C. Where he says Q, I'll think of M, and I'll do it in Roman numerals. You certainly could do that if you wanted to. You could also do it in terms of our Egyptian numerals, if you wanted to. But the important thing is, I would like you to think these problems through in terms of these symbols. I want you to actually go through the trauma of trying to memorize what these things stand for and how cumbersome the things become. Okay? Because basically, since we assume that people look for the simplest solutions to any problems that plague them, there should have been a reason why people decided to go beyond Roman numerals and the like. And I want you to see gradually the flavor of what happened that brought about the innovations that took us from the hieroglyphics at the dawn of consciousness to our modern exponent notation today. So the first problem says, what number is named by, and please don't try to read this. It's not kipupun, it's 3 Q's, 4 P's, 2 O's, and an N. And here's the subtlety here. The letters of the alphabet are your nouns, and the number of times they appear are the adjectives. See, how do you read this? 3 Q's, 4 P's, 2 O's, and an N. 3 Q's, 4 P's, 2 O's, and an N. Now you have to remember what these nouns represent. Q stands for 1,000, P stands for 100, O stands for 10, and N stands for 1. Is there any logic behind that? No. That's what we mean by an arbitrary or an artificial language. Symbols are made up, and you just accept them. So we have what? 3 Q's, which mean 3,000s, 4 P's, which stands for 400s, 2 O's, which stands for 2 10s, 1 N, which stands for a 1. So we have what? 3,000, 400, 2 10s, and a 1, which in our modern notation would be read as 3,421 and would be written this way. This is obviously much less cumbersome than writing 3 Q's, 4 P's, 2 O's, and 1 N. But remember how we measure progress. We measure by what the thing replaced, not what it was replaced by. Granted that this is less messy than this, keep in mind that 3 Q's, 4 P's, 2 O's, and an N is certainly a lot more convenient than having to write 3,421 separate tally marks. The next problem I want to do with you shows you the difference between when you need a placeholder and when you don't. In other words, as long as the nouns are visible, the absence of the noun tells you you have none of that denomination. See, problem number 2 says, what number is named by Q, Q, N, 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 N? Well, that's just another way of saying what? We have 2 Q's and 4 N's. Again, see, the noun is the letter. The adjective is that implicit little thing. We don't see the adjective. You see, we have to count it. See, we don't see a 2 here. We have to count 1, 2. You don't see the 4 for you. You have to count it. 1, 2, 3, 4. But what do we have altogether? 2 Q's, which means 2,000s. 4 N's, which stands for 4 ones. What do we have altogether? 2,000s and 4 ones. I don't have to put down, hey, there are no P's and no N's here. In fact, if this were Roman numerals, how would we write it? See, 2,000 would be 2 M's. Okay, I'm just going to change pens again here. See, 2,000 would be 2 M's. And a 1, I'm sorry, what did I write? This is silly. I hope this course gets better than this. See, 4 N's are 4 ones. Then I would write 1, 2, 3, 4. And I wouldn't say there are no C's and no X's. How do I know there are no C's and no X's? Because there aren't any there. See, I have 2 M's and 4 I's. And here you see, I put down a 4 in the ones place. Then to indicate that I have 2,000s, I have to skip what? The tens and the hundreds. So in that sense, I need the placeholder. You see, I don't need the placeholder as long as the nouns are visible. I don't care whether they're letters of the alphabet or whether they're lines in the sand. As long as there's a way of seeing the denomination as a noun, I don't need a symbol to tell me that I have none of that denomination. Now, again, to emphasize quality versus quantity, you see, I want to show you that it's not just the number of characters that appear, it's how potent they are. See, which name's the greater number, a single P or 6 O's and 5 N's? There are certainly many more characters over here. But remember, the 1 in 1P, P stands for 100. The 1 in 1P is modifying 100. See, 1P is 100. The 6 O's, on the other hand, the O's stand for 10. That's 6 tens. And N stands for 1. So 5 N's stand for 5 ones. It's sort of like in terms of money. If you have 6 $10 bills and 5 $1 bills, you have 11 bills worth $65. But if you have just a single bill and it's $100, you have, what, more purchasing power than all these other bills put together. See, again, the adjective and the noun, the quality versus the quantity. Reminds me of a story about the 3 Texans who are discussing how much property they owned. And one says, my spread is 1,000 acres, and I call it the bar triple B. The other guy says, well, I have 2,000 acres, and I call it the bar quadruple E. And the third guy was very quiet. They said, how big is your spread? He said, 7 acres. He says, that's not very big. What do you call yours? He says, downtown Dallas. I mean, there comes a time when it's the quality rather than the quantity that's important. You see, don't get blinded by the adjectives. When you say 7 or 70, it's always 7 what, 70 what. See, it's the adjective and the noun together that name the number. Okay? Let's continue on this way. Number 4 says, without using more than 9 each of N, O, P, and Q, write 5,632. And this is where the reading comprehension comes in. We have to be able to recognize the denominations and then figure out what the adjectives are. For example, we see the word 1,000. That's one of our nouns. What's modifying the thousands? The 5. See, so I have 5,000s. I catch the word 100 over here. How many hundreds do I have? 6. The 30 is a little bit suspicious here. We've got to be careful with that one. You don't see the word 10 in there. You see 30 stands for 3 tens, and then you have 2 ones. So what do you do? Break this down so it's easier to read. 5,600, 3 tens, and 2 ones. Now the symbol for 1,000, the numeral for 1,000 in this discussion is Q. The numeral for 100 is P. The numeral for 10 is O. And the numeral for 1 is N. So I rewrite this as what? 5 Q's, 6 P's, 3 O's, and 2 N's. And the part that I wanted you to see here is that because the nouns are visible, I can rearrange these any way I want. I've written the answer in a very silly form. You don't have to do it that way. I've done it that way to show you that as long as the nouns are visible, I can stack them any way I want. For example, to write the 5 Qs, I'll use the Egyptian method of 3 in one line and 2 in the next. Now, in order not to waste any space here, I'll write the 6 Ps by putting 3 on this line and 3 on this line with the first P under the third Q over here. Then I'll write in the 3 O's like this, and then the 2 N's will fit snugly underneath the 2 O's. I mean, this is kind of a weird type of setup. But you don't say, gee, how do I know whether this is 1,000 or 100? They're in the same column. No, wherever a Q appears, it stands for 1,000. Wherever a P appears, it stands for 100. Wherever the O appears, it stands for 10. And wherever the N appears, it stands for 1. So no matter how I write it, what do I have here? I have 5 Qs, 6 Ps, 3 O's, and 2 N's. And I can write them in any order I want. I could have put the P's first if I wanted to. I could have put 4 of the Q's over here. I could have put 2 O's here, 2 N's here, an O here, and then another of the Q's over here. The important thing is what? When I get all through, I have to have 6 P's, 5 Q's, 3 O's, and 2 N's. It's very similar to taking a whole bunch of bills and money and shuffling them up. No matter how you shuffle it, you still have the same amount of money, unless you shuffle kind of rough and you lose some of the bills. But basically, a $10 bill is a $10 bill, whether it's at the beginning of the pile or at the end of the pile. You see, so basically this is the nice part about the nouns being visible. But the bad part about the nouns being visible is that if there are too many of them, the adjective becomes overwhelming. Remember, how do we get the adjective that modifies the noun? We count how many times that symbol appears. So I've taken the liberty, by the way, of rearranging the symbols so that I could get these all written within a comfortable span of the camera. But basically, this says what? I'm going to take what numeral here? The numeral that consists of 2 Q's, 11 P's, 9 O's, and 14 N's. And if you look at that in the study guide, you're saying things like, my God, how does he expect us to count those? I actually want it to be hard for you to count. Because if it's easy for you to count, you're going to wonder why we had to get into modern place value. I want you to see how quickly this becomes cumbersome. So I want you to see how quickly this becomes cumbersome. I've stacked these so that they look easier for you. But the important point is the problem says what? Because we can trade in 10 of any one denomination for one of the next higher denomination, we don't have to put up with too many of any one denomination. See, basically what I'm going to do over here is, since N stands for 1 and O stands for 10, every 10 N's allows me to be replaced by 1 O. See, I can count what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I trade in 10 N's for a single O. Now, 10 O's are worth a P, so I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Trade those in for 1 more P. Every 10 P's are worth a Q. By the way, notice that I can't trade in anymore. See, if I still had more than 9 left, I could trade in again. But I haven't made the problem that complicated. So I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives me 1 more Q. So now that whole mess can be replaced by what? Whatever isn't crossed out. What do I have here? I have 3 Q's, 2 P's, all the O's are gone, and 4 N's. So if I stack that down here, what do I have? 3 Q's, 2 P's, and 4 N's. And I don't write, well, I'm writing it now, but I don't say, and no O's. There are no O's, and the reason that I know that there are no O's is that none appear. And again, notice in place value notation, this would be 3,204. Okay? Now, what's the problem with this particular system? Every time you want to come to a new power of 10, you need a new letter of the alphabet. So in problem number 6, I reintroduce, remember all of these concepts have been done in the study guide and the textbook, so I'm not introducing anything new here, but in terms of reviewing what was in the module, I'm doing some reviewing here. Now I introduce the sand reckoner, the one in which you no longer pick a different letter of the alphabet, but rather you draw lines in the sand, where each line represents a different power of 10. In other words, starting with the line furthest to the right, as you read from right to left, it's the 1s, tens, hundreds, thousands, 10,000s, etc. And so the problem says, what number is shown on the sand reckoner below? And I don't know how nicely I've drawn this. My producer helped me with this one, so if it came out good, I did it. If it came out bad, he did it. But anyway, there are what? 3 pebbles on this line, 2 on this line, 5 on this line, 1 on this line, 4 on this line, and none on the rest. Now see, using our modern Hindu Arabic notation, I can do what? I put a 3 here. I'm going to try and find something that writes real dark. Hopefully we can, so I just want to make sure you can read it okay. Put a 3 here. There are 2 here, so I put a 2 over here. See, 3 here, 2 here. There are 1, 2, 3, 4, 5 here. There's 1 here, and there are 4 here. Now, ordinarily, this is fine. I could stop right here as long as the lines are visible. I don't have to tell you that there are none here, 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 or here, because if there was some there, I would be able to see them. But now if I erase the lines, oh, by the way, if any of you have an aesthetic sense of values, I drew these lines unevenly on purpose. I also left the spacings between them slightly uneven, because what I wanted to impress upon you was that all you care about is the position of the line. In other words, this is the first line, second line, third line, fourth line, fifth line, sixth line, no matter whether it's longer or shorter or further apart or not further apart. The problem is, when I erase the lines, I've got to have a placeholder. So basically, for every line that had nothing on it, I have to replace that by a 0. See, there were none on this line, 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 none on this line. Now I put the commas in at 3-digit intervals, and that's the number. By the way, all it says is what number is shown. This is the number that's shown. You may decide, how do I read this? Remember what we agreed on? That most people can recognize 3-digit numerals. So we go by 3s, and the first group of 3s are called the units. The next group of 3 are called the thousands. Okay? The next group of 3 are called the millions. The next group of 3 are called the billions. And the next ones are called the trillions. And do you notice how this makes things easier to read? Because now I never have to keep track of more than a 3-digit adjective at a time. See, I have what? 3 trillion, 251 billion, 400 million. See, and don't leave these zeros out, because if I leave these zeros out, how will I know that the 400 is in the millions place? So basically, this is how you would write that number, and the way you would read it is 3 trillion, 251 billion, 400 million. And I want you to get used to the difference between the numeral and the number, the difference between the symbol and the concept. And that's what I want to do in problem number 7. Problem number 7 is a 2-part problem. It's kind of a chintzy problem in the sense that I'm getting kind of technical. It may sound like I'm being picayune and making a lot out of nothing, but it's a very important concept. A and B sound almost alike. Part A says, at $1 per object, what is the cost of 300 objects? Well, if you're paying $1 for each object, you're paying for 300 objects $1 300 times. So in other words, at a rate of 300 times $1, you're going to be paying $300. In other words, in terms of tally marks, imagine that you have 300 tally marks here, 1 for each object, and now you're paying what? $1, $2, $3, $4, $5, all the way up to $300. That's all Part A says, okay? At $1 per object, you're paying $300 for 300 objects. Now, Part B sounds almost the same, but it's significantly different. Part B says at $1 per digit, what is the cost of the numeral 300? See, Part A was a number problem. Part B is a numeral problem. You see, the numeral 300 consists of 3 separate digits, a 3, a 0, and another 0. And what happens over here is what? Each digit is costing you $1. So the 3 is costing you $1, the 0 is costing you $1, this 0 is costing you $1. You don't say, I don't pay for the 0 because the 0 is nothing. No, it's still a digit. And you don't say, hey, why should I pay you for this 0? I already paid you for this one. No, this 0 is needed to distinguish 30 from 300. So you're paying what? $1 3 times. And the thing that I want you to see over here is that this number represents 300 objects, but I can represent it by using just 3 digits. In other words, by the use of 3 single digits, I can represent 300 objects. And that's the beauty of place value. This is nothing compared to some of the numbers we'll be talking about later in the course, or in fact, later in this module, actually. And I would like to make a little aside over here. Everybody was wondering what this means. It was just a little gadget to separate out a little nonsense riddle from the rest of the stuff. So this is so non-funny that I'll have to label it riddle so you'll know it was a riddle. A man goes into a store and he wants to buy something. And the clerk says to him, 5 will cost you $3, 9 will cost you $3, 15 will cost you $6, 40 will cost you $6, and 320 will cost you $9. All the objects were equally priced. They all were equally priced. What was he buying? Well, it's hard to say for sure, but the thing I hope you noticed from the last problem, it was probably house numerals at $3 a digit. See, at $3 a digit, the digit 5 would cost $3. The digit 9 would cost $3. You see, the 15 is 2 digits, so you'd pay what? $3 for the 1 and $3 for the 5. So that would be $6. 40 is 2 digits. You'd pay 3 for the 4 and 3 for the 0. That would be $6. And 320 would be $9 because you have 3 digits and you'd be paying $3 each. It's a cute little riddle, but I think it does hammer home once and for all the difference between the numeral and the number. Okay? Just for fun. We'll do more about this. And now, again, what was I trying to emphasize throughout the module? That as you get more and more notation, and you climb to higher and higher levels of sophistication, you get the reward of stumbling across problems that are so complicated that you never would have discovered them if you were still locked into the simpler mode. And what happens is, you not only discover these problems, but you find out that the problem is very similar on a much higher level to the one that you already solved. For example, the next one, and this is partly, well, that's okay, we can do it this way. Read the number. First of all, without the commas in here, this number would be almost impossible to even start to read. But with the commas, what does this tell me? I have 187 of one denomination, 813 of another denomination, and how many of another denomination? This is a little bit tricky, but be careful. 5. See, let me blow this up. You see, between the commas, there are always 3 digits. And the first digit stands for ones, the second for tens, and the third for 100. So in terms of this, see, you're skipping this denomination, you're skipping this denomination, and the 5 is going over here. So you have 5 of whatever this is. Then you have none of these, none of these, none of these. But how do you read what this stands for? Remember how we do this? You go to the very beginning, and the first group of digits, of 3 digits, are called the units. The next group of 3 digits are called the thousands. Then come the millions. Then come the billions. Remember, bi millions, billions. Then tri-millions, trillions. Then after that come quad millions, which we call quadrillions. So now we have finally fitted the nouns with the adjectives. We have 187 quadrillion, 813 trillion, 5 billion, period. We don't say, and no millions, no thousands, no units, because the absence of those denominations, see, when we're naming the nouns, as soon as we don't name a denomination, we have none. In other words, the way you read this number is 187 quadrillion, 813 trillion, 5 billion. See, that's the way you read it. So you don't say, and no millions, and no thousands, and no units. And what makes this even more cumbersome is that sometimes people insist on spelling the whole thing out. In other words, this is maybe tough enough for some people, but other people do this. They'll write 187 quadrillion, 813 trillion, 5 billion. In which case, what your job is separate out, locate those important nouns that we use for 3 digits. See, quadrillions, trillions, billions. Now can you reconstruct this? See, notice that once I've located this, what's the noun, what's the adjective over here? 187. Well, 187 isn't hard to read. You see, once I've located trillions here, what is the adjective? 813. 813. And once I've located billions, what's the adjective? 5. See, so from here, I could go to here. And from here, I could then go back to here. See, when I'm using place value, I have to put in what? 3 zeros to hold the place of the millions, 3 zeros to hold the place of the thousands, and 3 zeros to hold the place of the units. And let me make a few comments on that. You see, the important thing is I always have to have 3 digits between commas. For example, I have to write this. I will never write this. Well, I mean, I just wrote it here, so obviously I'll write it. What I mean is you don't write things like this, because the problem is, remember, there are supposed to be 3 places between commas. By leaving out the placeholders, I have no way of knowing, even though I've located this to be, see, what place is this? Units, thousands, millions, billions. So even though this is the billions place, I don't know whether the 5 goes with the hundreds, with the tens, or with the ones. In other words, is this 5 billion, 50 billion, or 500 billion? I have to have those zeros in there as a placeholder. And secondly, I never omit sets of zeros. Suppose I said, well, I'll put the 2 zeros in here to humor gross, but we don't need these zeros over here. Let's just get rid of them. So we write down 187 here, 813 here, and 5 here. But we leave out the rest of the zeros. Look what's happened now. The 187, the 813, and the 5 are still the same old adjectives they always were. But you see, this has become the units. This is now the thousands. This is the millions. So now the number is what? 187,813,005 units. I don't know if we can drift back here a little bit just to show you. You see the adjectives 187, 813, and 5. Look what happens over here. The adjectives are 187, 813, and 5. That hasn't changed. But the placement of the zeros is the difference between the 187 modifying quadrillions and, say, the 5 modifying billions, than having the 187 modifying millions and the 5 modifying units. You see, they go together, adjectives and nouns. You start to follow the idea here. And you may make fun of this. It may look like we're doing baby stuff. But believe me, take my word for it, that when we get to higher mathematics, and I don't just mean higher arithmetic, higher mathematics, this adjective-noun theme becomes very, very central throughout all of mathematics. In fact, if you stay with me through this entire sequence that hopefully someday will go from arithmetic through calculus, the theme of number versus numeral will come up at every possible level. And that what you'll discover is that even as your level of sophistication changes, the same problem of confusing the number with the numeral will cause tremendous headaches for you. So you might as well learn it correctly now. What's that commercial? You can pay me now or you can pay me later. Just pay me. No, just a joke, okay? Anyway, let's now go back and revisit this problem by doing it from the opposite point of view. See, problem number 9 does the inverse of problem number 8. In problem number 8, we started with all of the digits and asked you to read the number. In problem 9, we're going to start with the verbal form and ask you to write it as a place value numeral. See, it says write as a place value numeral 804 quadrillion 537 million. And this is an overwhelming number. And what I'm hoping you'll learn to do here is what I'm trying to tell you. What are the nouns when you work with commas? Units, thousands, millions, billions, trillions, quadrillions, etc. So what I'm going to try to do here is locate those key nouns for you. So I read over here, see the 804, that may sound like a big number, but that's chicken feed compared to what I'm looking for. I'm not looking for anything less than 1,000. Here's the word quadrillion. I key in on that. Now I keep on going. 537, no, that doesn't interest me. Millions. So now I've located my 2 major nouns. What are the 2 major nouns? Quadrillions and millions. What do I need? I need the adjectives that modify them. So I go back to the beginning of the problem and I say, what modifies quadrillions? Well, 804 quadrillions. See, 804, that's a 3-digit number, 804. So I can do that pretty easily. What modifies million? 537. Well, 537, that's an easy 3-digit number. That's 537. So what do I have? 804 quadrillion, 537 million. Now, how do I locate the zeros? What comes between quadrillions and millions? See, before quad comes tri, and before tri comes bi. So it's trillion and billion. So what I could do is this. I start with the 804. I write that down. Now, that's quadrillions. How many trillions do I have? None, because they're not mentioned. How many billions do I have? None, because they're not mentioned. So I have none in the billions place, all right? I'm sorry, none in the trillions place, none in the billions place. How many in the millions place? 537. Now, how do I know it's the millions place? I'm using place value now. I have to make sure I've told you that the 537 modifies millions. So I say what? And 0 thousands and 0 units. See? 000, 000. And by the way, just to make an anecdote out of this, after I told you how easy it is, as I was checking the study guide, I noticed that the first edition incorrectly uses 037 instead of 537. In other words, in the first edition of the study guide, incorrectly, the 5 is replaced by a 0. So take that for whatever it's worth. But do you start to follow the idea? Now, some people have trouble counting backwards, so to speak, over here. In other words, they say, I understand quadrillions. How am I supposed to remember that I skipped the trillions and the billions? You see, people tend to memorize in the direction they learned it. In other words, we taught this as what? You go from units to thousands to millions to billions to trillions. Now when you start counting back the other way, it gets kind of confusing. It's sort of like asking a person to recite the alphabet backwards. My son does that. He just turns around and says A, B, C. That's reciting the alphabet backwards. But I mean, going from Z to A. Reciting the alphabet A, B, C, D, E, etc. shouldn't be any different from saying Z, Y, X, W, V, U. But it takes us time to think about it because we're used to going in one direction. Should that happen, don't panic over it. Go back to the beginning of the problem and you say, let's see, I want 804 quadrillion and 537 million. So let me see. You say, I don't remember. I have to go back to the beginning. I remember that these 3 digits, the first 3 digits are called units. Then there come thousands. Then there come millions. Then there come billions. Then there come trillions. Then there come quadrillions, okay? And you say, now, what did they tell me in this problem? See, I'm going to look back over my shoulder. You don't have to watch this. It was what, 804 quadrillion? So I put the 804 in the quadrillions place. Then there was what, 537 million? So I put the 537 in the millions place. Now, how would I read this so far? 804 quadrillion, 537 million. Do I need any zeros in here right now? No, because the trillions are still labeled. I have no trillions. The time I need the zeros is when I want to leave out the nouns and replace them by commas. You see, then what I do is, to set the stage, I put the zeros to lock in my nouns. Then where these blue vertical bars are, I put in commas. And once I've done that, what can I now do? I can erase the nouns. I can erase the little dashes here. I can erase the vertical bars. And what do I have? 804, comma, 3 zeros, comma, 3 more zeros, comma, 537, comma, 3 zeros, comma, 3 more zeros. It just takes a little practice, get used to it, and see how magnificently we have allowed ourselves to handle big numbers by sneakily trading in bundles of 1,000 rather than in bundles of 10. But even with these big numbers, you can see how quickly we get into trouble, and that was why we introduced scientific notation, exponents at the end of the module, and I just want to check up on you to make sure you understand that notation. Problem number 10 is kind of a sneaky one because, you know, in a true-false statement, it's either true or it's false. It's not part true and part false. But sometimes you write the statement in such a way that it looks like it's about 99% true, and you're afraid to say it's false just because the little bit that's false. But look what happens over here. I said 10 to the 7th power. Remember, 10 is called the base, 7 is called the exponent. This is read as 10 to the 7th power, okay? And that's called a power of 10. 10 to the 7th power is 10 followed by 7 zeros. Is that true or false? And the answer is, it's false. What it really is a 1 followed by 7 zeros. And the way to remember that, the mechanical way of remembering that, is read the number as if it was written this way. See, box off the 0 and the exponent. And now what you say is what? It's a 1. See, there's the 1 over here. See, it's a 1 followed by how many zeros? 7 zeros. Now, the reason for that, by the way, you can say, well, big deal. You want it to be a 1 followed by 7 zeros. We think it's more natural to have a 10 followed by 7 zeros. Whenever possible, you will never have to take my word for anything. I will always try to give you one of two things. Either the history about why the agreement was made, or else I will show you why what seems simpler is wrong, and hence we can't use it. In this particular case, it's not a case of right or wrong. It's a case of usage. You see, when you multiply 10 by 10, the answer is 100, right? If you count by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. See, so 10 tens is 100. So if you take 10 and multiply it by itself, you get a 1 followed by 2 zeros. This notation of 10 to the second power is an abbreviation for saying you're multiplying together two tens. What happens when you multiply together two tens? How many zeros follow the 1? 3 zeros, 1 zero, or 2 zeros? 2 zeros. In other words, by making our definition, the exponent will tell you how many zeros there are in the number. For example, going back to the problem I gave you here at the beginning, when I say 10 to the 7th power, what does that mean? It means a 1 followed by 7 zeros. What that means is, and we'll do this later in Module 3, if you multiply 10 by itself 7 times, what you would wind up with is a 1 followed by 7 zeros. But you don't have to know that now. All you have to do is take my word as to what this means. In other words, 10 to the 7th power means a 1 followed by 7 zeros. So what do? I write the 1. I follow it by 7 zeros. See? 1, 2, 3, 4, 5, 6, 7. And that's hard to read, so I put my commas in. Now it's even harder to read because I put those numbers in underneath. But what do I have over here? 10 million, right? See, no units, no thousands, but 10 in the millions place. So this takes the place of what? 10 million. In other words, by writing a 10 with a little 7 on top, I have taken the place of what ancient man would have had to have written 10 million tally marks for. And can you visualize that any problem that required 10 million tally marks would never have been conceived of? You see, basically, by expanding your means of communication, you also broaden the horizons for the degree of abstractness that you can think with. You see, it's almost inconceivable to think of large numbers that we need today without using exponents and place value. And as long as people were locked into hieroglyphics, there was no chance that they were going to advance significantly. This is the trade-off in life. If you want things to be simple, that's great, but you probably won't go very far. But if you want to make progress, you're going to have to use certain degrees of sophistication. And that's basically what this problem here is designed to show you. By the way, the person who said it's a 10 followed by 7 zeros, that would be what? See, a 10 followed by 7 zeros, if I started with 10 and then put in 7 zeros, 1, 2, 3, 4, 5, 6, 7, that would be what? A 1 followed by 8 zeros, which would be called 10 to the 8th power. That's 100 million. So what's interesting is that 10 to the 7th gives you 10 million. How many digits there? 8. 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th power is 100 million. That gives you 9 digits. See? 3, 6, 9. Now, what's the biggest number that's less than 100 million? It's 99,999,999. In other words, there's a lot of numbers between 10 million and 100 million, aren't there? In fact, there's a lot of them. There's 90 million numbers there. But the point is that just by changing this exponent from 7 to 8, you bound all of them. In other words, what is the smallest 7-digit number? 10 to the 7th power. What's the biggest, let's say 7-digit, 8-digit number is 10 to the 7th. What's the biggest possible 8-digit whole number? 1 less than 10 to the 8th power. See, there's what? See, the smallest 8-digit number you can have are 7 zeros and a 1 over here. The biggest you could have is 8 nines. So basically, here's the end of our saga. We have 90 million numbers. 90 million numbers between 10 million and 100 million, yet we can keep track of those just by an exponent on 10 that varies between 7 and 8. In other words, by suitably, and this comes up in algebra and more advanced math, but by suitably inventing a new notation, we can represent every whole number from 10 million to 100 million just by the right number to multiply 10 to the 7th power. And that's what we mean by orders of magnitude. At any rate, I don't like to get too philosophical during the exercise sets. And the reason for that is that the exercise sets are designed to see whether you've learned the material in the module. Now, if a student has learned that material, there's a chance that they're not watching this lecture. You see, basically, everybody should be watching the enrichment lectures. But the only people who, by necessity, should be watching the problem-solving lectures are those who couldn't get the problems right. Now, that doesn't mean that other people aren't watching them, but it does mean that they may not be. So anything that's really worth knowing, I would like to make sure stays in the enrichment lectures. On the other hand, as a reward for those of you who are willing to plow through these problems with me, I would like to leave you with a little bit of enrichment that makes it worth your while to have stayed with me. Meanwhile, in terms of our opening preface lecture, I'll close again with, I think I've given you enough for today, and what I'd like you to do is make sure you understand this, start looking ahead towards Module 2, and in the meantime, what are you going to do? You're going to study hard, have fun, and stay young.